All right, we are back, and we are back. Okay, constraints we left off. We're going to make some constraints. We're going to write some inequalities, actually, and this is going to be from the stuff that I highlighted above. So our variables are W and R, and we have some constraints on that. Look at the first one. A farmer has 10 acres to plant. Okay, well, W is the acres of wheat, and R is the acres of rye. So that means that together, W and R cannot be any more than 10. So that has to be less than or equal to 10. There's one constraint. Cannot go over 10. Second sentence, it says he has to plant at least 5, so he has to use at least 5 of his acres. So that is also related to W plus R, and that has to be greater than or equal to 5. So somewhere in there. I kind of forget this every time, but there's some obvious ones here, and that is we are not going to be planting negative acres of something. So that means that W has to be greater than or equal to 0, and so does R. And these ones are very common. So you'll commonly see those when you're doing problems like this. There's one other thing the farmer is limited by, and that's the amount of money he can spend. He has a $1,200 budget, and for every acre of wheat he plants, it costs $150. So what that means is it's going to cost him 150 times W plus it's $100 for every acre of rye, and that combination has to be less than or equal to $1,200. So he could spend all of it. All right. So that gives us all of our constraints, I believe. And the only other thing we need to write is the objective function, which is basically what we're trying to figure out here is what combination can we should we do to get this farmer the most profit. And so profit is going to be represented by, now let's think about what it says above, $500 per acre of wheat. So that's going to be 500 times W. Okay, and then you also have to account for his rye, which he gets $300 for every acre of rye, which this probably makes completely, this is probably totally inaccurate for any farmers out there. But you know how the math book goes. So there is our objective function. We're going to use that to maximize the profit. So now we're going to move to the next page, and we are going to graph this. So we're going to take these constraints and we're going to put them on a graph. So I will go ahead and copy and paste those. So here we are on the next page with some graph paper, and we are going to go ahead and just graph all these constraints. So let's go ahead and we'll use some color, and let's graph let's do the first one in red. So we'll do the first one. The amount of acres he had cannot be more than 10. So this is an intercept. This is a nice intercept form, Bolio intercept form. So let's use the intercepts here. That means when W is 0, R, let's label our axes. So let's make this the W axis, and then we'll make this one up here the R axis. So when R is 0, then W is going to be 10. So we go over 2, 4, 6, 8, 10. I think that's 10. Yep. And then R, same thing. Go up 10. So when W is 0, R is 10. So we're going to go up to 10, 2, 4, 6, 8, 10. And there is our first constraint, and that is going to be a solid line through those 2 points. So I'm going to make a solid red line here through those 2 points. And I'm just thinking ahead. Since W and R both have to be positive, we're going to be in the first quadrant. So I'll just stop my line right there so it doesn't get too cluttered. Okay, because if I look at these, and maybe I'll just do these right now in black, but you know, you have your R, your W and your R cannot be greater than or it has to be positive basically. So it's going to be in the first quadrant here. So essentially I have a triangle, right? And I have to be greater than 0, greater than or equal to 0 for R, greater than or equal to 0 for W, and then I have to be less than this W plus R together has to be less than 10, so I'm on this side of this red line here. Okay, I will have another line here. W plus R has to be greater than 5, so if I go and use the intercept form there, I'm going to have two intercepts that are the same at 5, and then I'll connect those two with a line. And I have to be greater than this line, so I need to use at least 5 of the acres. So for this one, I need to be above that line. All right. Now my last one then has to do with the cost, and this is another great one for using the intercepts to graph. So if I go ahead and take a look at the intercepts here, the R-intercept, oops, let me erase that. All right, the R-intercept is going to have a W value of 0. So we're talking about on the R axis. So W is 0. And W is like my X, so that will be first. So when W is 0, what is R? Same concept for the W intercept. That's like your X intercept. At the X intercept, we know Y is 0, or in this case, R is 0. So when I put 0 in for W, okay, so if I cover up, essentially I cover up and I put 0 in for W, that basically just gets rid of that for now. So if you just block that out, when is 100R going to equal 1200? And of course that's at the X value of 12. Because if you take 100 and divide both sides by 100, 1200 divided by 100 is 12. So my R-intercept's 12. And if I do that same thing and I cover up and I put 0 in for R, basically it makes that 0. Okay, when does 150W equal 1200? That is when W is 8. Okay, so this is perfect for intercepts. Whoops. So I'm going to go ahead and graph this final line here, and we'll make this the blue line. And the blue one is going to have a R-intercept of 12. That's going to be way up here. And a W-intercept of 8, which will be 2 back from the 10 right here. So if I connect that with a solid blue line, it's going to look something like this. And we need to be less than that, so we need to be below that. So we're talking about being below that here. So basically we have our feasible region all set up, and then you just want to shade it in with some sort of, like probably using your pencil. So I will shade this in with a highlighter here. So we're talking about all the values right in here. So below the blue line, slightly bends here below this red line, and then above the green line, and then to the right of this. So we're talking about any point in here would be a good combination. That would satisfy all of our constraints. So that right there